Gauss-Jordan elimination. So just take a moment, pause it, read over this. Okay, there's a 3-step model here. Please read over it. And then right above example 1 is some explanation on how to perform or how to read while performing row operations. And if you see here on part A, it says we're going to take row I and interchange it with row J. Part B says that we're going to take some constant, times it to row I, and we're going to put it right back in row I. C says we're going to take some constant times row J, add it to row I, and put it back in row I. So that's what that notation says. So let's perform some row operations on example 1. It says that we're going to take -6, times it to row 2, add it to row 1, put it back in row 1. So what I'm going to do, and I'm going to rewrite this, just you can come over here and list it if you want, or if you want to leave it in a matrix form, you can. We know that we're putting everything back into row 1. So I'm going to take -6 and I'm going to multiply it to row 2, which is this right here. So it's going to be -6 times 4, and we're going to add it to row 1, which is this row, plus 0. -6 times row 2, add it back to row 1. I'm going to put my equal sign here. That's what that bar is for. And then I'm going to say -6 times row 2, add it back to row 1. And then since we're not changing row 2, I'm just going to go ahead and carry it over here. And I'm going to clean up my math here. So I got -6 times +4 is -24 plus 0 is -24. -6 times -7 is +42 plus a -2, so it's +40. -6 times -2 is a +12. I'm going to add 3 to it, so I get 15. And then we're just going to rewrite it neater. And this is my answer. This is my answer using that operation. Okay. So now let's move on. Above example 2 has some explanations. Whenever you did system of equations, we know we get either a solution. If we can get an order pair x, y, we know we got a unique solution. If we get, say we got 5 is equal to 5 when we're doing elimination or substitution method in the system of equations, and we were trying to get what x and y is, but we didn't get it. We just got some constant equal to a constant. If it's a true statement, then we have infinite many solutions. However, if we had a constant equal to another constant and they're not equal, then it's no solution. Well, it's going to be the same way here in the matrices. So what we need to do is we need to get it written where we have ones in our diagonal and zeros everywhere else. Once we have that, and then it's going to be equal to some number. Once we have that, then we know what this is. So in this textbook, they used x1 and x2 instead of x and y. So whenever we solve for that, I know that right here it gives me x1 equals to a number. And this one here gives me x2 equal to a number. Then that means we know what x1 and x2 is. That means we get a unique solution. So that's our goal. If it happens or not, it's a different story. So let's go ahead and write our matrices out. We got 7, -1 equal to 41. And then we got 1, 8, 14. And now let's solve for it. Well, I want a 1. I want a 1 in the first row, first column. And I notice that I have one in the second row, first column. So if I just said, oh, okay, I'm going to take row 1, interchange it with row 2. That means I'm going to put row 2 up here at the top now. And what happens is I got my 1 where I want it. So next, I'm going to perform a row operation where I can get 0 underneath that 1, because that's our goal, right? We want 0 underneath it. So to perform that, I can say, okay, if I take -7 and I multiply that by the row 1 and add it to row 2, put it back in row 2, what happens? So that means row 1's not changing. But I'm going to take -7 times row 1 plus row 2. -7 plus 7 is 0. I'm going to take -7 times row 1, add it to row 2. -7, so I've got negative times a positive, which is a negative. And then I got 7 times 8, which is 56. And then I have, so that means I have a -56 plus a -1. That gives me -57. All right, so now I got 14 up here on row 1. So row 2, I'm gonna have -7 times row 1, add it to row 2. So we have -7 times a positive 14. And then we're going to add that to a, what's a -98, right? Add that to a 41, and it gives me -51 or 57, -57. Okay, so far so good. Now we want to, and you want to double check, make sure that the math is correct, okay? So the next thing, I got my zeros where I want it, right? And if you want to double check your math, 7 times 14. All right, yeah. All right. I got the 0 where I want it. I'm just going to rewrite it just so I can see it. I got a 1 and a 0. That's what we want. Now I have 2 things left to do. I need that 8 to become 0, and I need that -57 to become a 1. I went ahead and wrote it, but it's not right. But I want it to become a positive 1. So what if I said a -1/57 times row 2 and put it back in row 2? Well, I got 1 over -1/57 times 0. Well, that's just 0. A -1/57 times -57. Well, a negative times negative is positive. 57 goes in 57 once. Put the 8 above it. So now I got 14 over here. Okay, so now let's take the -1/57 times, and I see a typo. So this is easy to do whenever we are rewriting our numbers. It's easy to transpose them, so it's very important to double check. And I just caught my answer. So this happens, guys, to the majority, and it might not happen to you all the time, but every now and then there will be that one time. So just double check your numbers when you carry them over. So -1/57 times a -57 gives me 1. I'm going to rewrite this, and I'm almost done. I want this 8 to become a 0, and then I will know that it would be a unique solution, right? So let's solve for it. Now to make 8 become a 0 here, I can say, okay, let's do -8 times row 2, add it to row 1. Add it to row 1 and put it back in row 1. So I'm going to do that. So I got -8 times row 2 plus row 1 gives me 1. -8 times row 2 plus row 1 gives me 0. -8 times row 2, add it back to row 1. So that's basically saying I got 14 minus 8, which is 6. And now let's write everything for row 2. And I'm going to rewrite this, clean it up. Again, just make sure we watch what we bring over. So now that I have this, I do know I have a unique solution. And I know my unique solution is when x1 is 6 and x2 is 1. All right, so let's move on. Example 3 says use the row operations to change the matrices to reduce form. Well, if you notice, they already got it set up for you with a 1, 0, 1. So the only thing left to do is to take that 4 and make it a 0, and then we have our reduced form here. So I noticed that if I said, okay, I'm going to take -4 times row 2, add it to row 1, put it back in row 1. So now this says I got -4 times 0 plus 1. Well, that's just 1. -4 times 1 plus 4. Well, that's 0. -4 times 5 plus -3. So that gives me a -23. And then let's bring everything over. Now that I have that, I'm going to rewrite it nicer and neater. And now I know x1 is 1, x2 is 5. Some textbooks uses x, y, and z if we have 3 unknowns. This one is just using x1 and x2. Okay, example 4. Example 4 says use the row operation to change the matrix below to reduce form. So what I notice is that I'm on a good row here. I got 1, 0, 0. That's great. But I got a 1 here. It's a -1, but I can work with the negative, right? So what if I switch these two because I want that 1 there? So let's take row 2 and interchange it with row 3. So be careful when we write these down. Oops, see, be careful. We're interchanging these rows. So this becomes this. All right, so far so good. So now that I've interchanged those, I can say, okay, let's take -1 times row 2, put it back in row 2. So let's do that. 1, 7, -7, -1. So -1 times 0 is 0. -1 times -1 is 1. -1 times 6 is -6. And -1 times -1/8 is just a positive 1/8. Let's bring everything else over. All right. So now I have a diagonal going, right? We got it started. So next, let's get a 0 in the, right here. Let me show you. Let's get a 0 right here. So what am I going to do? I'm going to say, okay, -7 times row 2, add it to row 1, put it back in row 1. So when I do that, so what do I get? I get -7 times row 2, add it to row 1, which is a 1. Okay, there we go. So it gives me 1. -7 times row 2, add it to row 1. That's what we wanted. -7 times row 2, add it to row 1. So negative times negative is positive. 7 times 6 is 42. We're going to subtract 7 from that, gives me 35. -7 times row 2 plus row 1. So now I have a -7/8 plus a -1 gives me a -15/8. Okay, so it's row 1. Now let's just bring everything else down. Okay, I'm going to rewrite it to be neater, but again, just watch what we write down. Try not to copy a number that's not supposed to be where you put it. Make sure it's correct. All right, so far a good start. Now I need a 0 in the place of where 8 is at. 8 down here in row 3. So to do that, I can say, okay, I'm going to take -8, times it to row 2, add it to row 3, put it back in row 3. So I got 1, 0. So I got -8 times row 2. I'm going to add it to row 3. -8 times row 2, add it to row 3. That's what we wanted. -8 times row 2, add it back to row 3. So I got 8 times 6 is a positive, -8 times -6 is a positive 48, plus a -48 gives me 0. -8 times row 2, add it to row 3. So -8 times that 1/8 gives me a -1 equals -1 plus 1 is 0. And we got something here. This tells me that I'm going to have infinite many solutions. Because I'm going to have 0 equals 0. So I'm not going to know this unknown here, right? Because it doesn't matter what I plug in, I'm going to get infinite many solutions. So we will be done with that one. We don't have to go any further. Okay. Example 5 says solving using Gauss Jordan elimination. So what we need to do is we need to rewrite this in our matrix C form. So we're going to take all the coefficients off the variable term. So I got 5, -11, 28 equals 97. I got 2, 25, -64, -249. 1, 2, -5, -21. All right. And the first thing I see is that I have this 1 right here, and it's in row 3. So I want it in row 1. So I'm going to switch them. I'm going to say row 1 interchange with row 3. And let's write it right here. So I got 1, 2, -5, -21. Got 2, 25, -64, -249. 5, -11, 28, 97. Okay, we're off to a good start. So now we want to get a 0 underneath that 1. We want this 2 to become 0. So what I could do is say, okay, -2 times row 1, add it to row 2, plug it back into row 2. So I got -2 times row 1 plus row 2. I got -2 times row 1, add it back to row 2. Gives me -4 plus 5, 25 is 21. -2 times row 1, add it back to row 2. So I got negative and negative times each other is positive. 2 times 5 is 10, -64 is a -54 equals -21. Got -2 times -21 plus a -249. And again, negative times negative is positive. So 2 times 21 is 42. I'm going to subtract that from 249. So it gives me a -207. Don't forget our negative sign. Now let's bring the rest over. And I'm going to rewrite it just to clean it up because it's a little bit of a mess. So I can see what row operation I need to perform next. I just got to be careful rewriting it. All right. So now I see that I need a 0 in row 3, column 1. It's a 5 there, so I'm going to make that a 0. So in order to make that 0, I need to say, oh, okay, let's take -5 times row 1, add it to row 3, put it back in row 3. Now that I've done that, let's go ahead and rewrite it. So I got -5 times row 1 plus row 3. Got my 0. -5 times row 1, add it to row 3. So now I got -10 plus -11 is a -21. -5 times row 1, add it to row 2. Or excuse me, row 3. So that's 25 plus 28. That's going to be 53. -5 times row 3, or excuse me, row 1. -5 times row 1. And then I'm going to add it back to row 3. So now I got -5 times -21 is a positive 105. We're going to say plus the 97. And that gives me 202. So I'm going to bring everything else over. And I'm going to rewrite it where it's just a little bit neater. 1, 0, 0. Doing good. Okay. So now I want to get a 1 in row 2, column 2. So to get a 1 there, I'm going to say, okay, let's take 21 and turn that to 1. I can go, well, half times row 2. Put it back in row 2. So I got 1. 0 times a half is 0. Or 121s. 121s times 21 is 1. 121 times 54 is 18/7. 121 times that -207 gives me 69, a -69/7. I'm going to have to get another paper. I didn't give myself enough room. So let me get this rewritten. And then let me get that. I'm going to rewrite this right quick. I got 1, 0, 0, 2, 1, -21, -5, 18/7, 53, -21, 69/7, 202. It should be a -69/7. Don't forget our signs. All right, let me grab another sheet of paper real quick. I'm going to finish this problem out. Okay, so let's rewrite this right quick. And we're going to want to turn, let me rewrite it and then we can talk about it. All right. All right, so now let's turn that 20, this negative 21 into 0. To do that, I'm gonna say, okay. Or actually, let's save that one for next. Let's do this one here. Let's turn this one to 0. So I'm gonna say -2 times row 2, add it to row 1, put it back in row 1. So now I got -2 times row 2, add it to row 1. -2 times row 2, add it to row 1. -2 times -18/7, add it to row 1. Oh, don't forget our negative sign. So negative times negative is positive. So I got 2 times 18/7, and then I'm going to add it to a -5. It gives me 1/7. My equal sign. So now I got -2 times row 2, add it to the row 1. Didn't give myself a whole lot of room there. Again, negative times negative is a positive. And we're going to add that to a -21. So I get -9/7. And then we're just going to bring everything else over. We're going to rewrite this where it's a little bit neater. All right. So let's rewrite it right quick. 1, 0, 0, 0, 1, -21. So that -21, we're going to want to change next. We're going to want it to become 0. All right. So to make that become 0, I'm going to say, okay, 21 times row 2, add it to row 3, put it back in row 3. So I got 21 times row 2, add it to row 3. 21 times row 2, add it to row 3. There, we got our 0. 21 times row 2, add it back to row 3. So we got what, 21 times that -18 divided by 7, and then we're going to add that to the 53. Gives me -1. Don't forget our negative sign. So I got 21 times row 2. And I'm going to add that back to row 3. So we got 21 times that -69/7. And we're going to add that to 202. And that gives me -5. And then, of course, we're just going to rewrite this neater. We're almost done. Okay, so let's rewrite it where we can read it right quick. So now we got to start on this third column. Actually, yeah, the third column, third row. Let's turn that -1 to a +1 by taking and multiplying -1 to row 3, put it back in row 3. All right. So -1 times 0, 0, -1 times 0, 0, -1 times 1 is -1 is +1, -1 times -5 is +5. And now we have, oh, we're almost there. And just rewriting this so many times, got to be careful. Just make sure that we don't like put a number in the place it shouldn't be. All right, so now let's start on column 3, row 1. I have 1/7 there. What if I said that I wanted to make that a 0? I can say, okay, -1/7 times row 3, add it to row 1, put it in row 1. Let's do that. So I got -1/7 times row 3, add it to row 1, gives me 1. -1/7 times row 3, add it to row 1, 0. -1/7 times row 3, add it to row 1, gives me 0. So that's what we wanted. -1/7 times row 3, add it to row 1. So I got a -5/7 plus a -9/7. And that gives me -2. All right, so I'm going to bring the rest of that over. I'm going to rewrite this and just make sure we got our signs right. Oops. Okay. Okay. Oh, and our last one here. So we got 1, 0, 0, 0, 1, 0, 0, -18/7, 1. -2, -69/7, 5. All right. We are on our last part. We need that -18/7 to go to 0. So to make it go to 0, I can say, okay, I'm going to take 18/7 times row 3, add it to row 2, put it in row 2. So let's do that. I'm gonna write this kind of big. So my row 1, leave it alone. So row 2, we got 18/7 times row 3, add it to row 2. 18/7 times row 3, add it to row 2. 18/7 times row 3, add it to row 2. And this gives me 0. 18/7 times row 3, add it to row 2. And so what do we get? Now we got 18 times that 5 divided by 7, and we're going to add that to the -69/7, and that's going to give me a +3. So I'm going to rewrite everything right here instead of keep writing it again. So I know I got 1, 0, 0, 0, 1, 0, 0, 0, 1, and then over here I got -2, 3, and 5. And now I know what they are. X1 is -2, X2 is 3, and X3 is 5.